In this video, we'll look at some other complications that can come with using substitution method to solve problems. So sometimes the change of variables you want to do to some u and du doesn't work out as neatly as it should, or as it could. There's a little bit more work that's involved in making this substitution method work, but it's not too terrible to make it happen. This first one we've seen before. What happens for this problem? Well, I should want to set my inside function to be u, so u is x cubed plus 9x minus 5, and so du is then 3x squared plus 9 dx, which I don't quite see in my problem, but I see a multiple of it. So then 1/3 du equals x squared plus 3 dx, and now that I see in my problem. Now I can substitute in and get this same thing becomes the integral of u to the fourth times 1/3 du, or 1/3 integral of u to the fourth du, which I can then integrate because that's the power rule. 1/3 times 1/5 u to the fifth plus c, and I plug back in my u. The issue here was just a missing constant that made me need one more step to make sure I could plug everything in properly to get to this answer. This next one here is a little bit trickier. So I have no way to really handle this at this point because I have an x on the outside and then a square root of multiplication on the inside. I have no way of dealing with that. The square root's more problematic though, so our goal should be to get rid of that square root, or at least make it a square root of a single variable, because I can do x to the 1/2. That's the integral I can solve. But the root of 3x plus 1 I can't solve. Let's set u to be 3x plus 1. du is then 3 dx. And so I'll get a 1/3 du equaling dx here to solve out. And I can plug in. So I'll get then the integral of x square root of u times a 1/3 du, which is 1/3 integral of x square root of u du. I have a slight problem here, and my problem here is this x. But when I'm doing the substitution, I have to get everything over into u. I can't leave any x's hanging around afterwards, because I don't know how to handle them anymore. My integral is now in u, so everything has to be in u to make this work. How can I deal with this x? Well, I can deal with it because I have an expression here, and I can try to solve out for x in that expression to then plug in. So this gets me that u minus 1 equals 3x, or x equals u minus 1 over 3, which I can plug into here. And if I do that, I will get that my integral becomes 1/3 integral of u minus 1 over 3 times root u du, or a 1/9 integral of u minus 1 times square root of u du. How can I handle this? What I can do now is distribute that root u in the parentheses and just add powers, because that's how powers work. So I get a 1/9 integral of, this is a u times root u, so that's going to be a u to the 3/2 minus a u to the 1/2 du. And now these are both powers. It's basically a polynomial, but they aren't integers. I can just integrate this. This is not a big deal. So I get 1/9 times u to the 5/2 over 5/2 minus u to the 3/2 over 3/2 plus c, or plugging in my u, which is 3x plus 1, 1/9 times 2/5 3x plus 1 to the 5/2 minus 2/3 3x plus 1 to the 3/2 plus c. That one works out pretty nicely, but the trick there becomes I have this x still floating in my expression. How do I manipulate my equation to get rid of that x? And the idea became, let's solve out for x in the substitution that I made and see if that helps. If you can't solve out for x, but you need to, there's likely a different substitution you should try to make your life easier to solve this problem. And let's look at this for one last example. What should we pick for u here? Well, for u, we should pick the most inside thing. We're going to pick u to be 2 plus 3 root s. That's the most inside thing that I see here. Which gives me that du should be a 3 times 1/2 s to the minus 1/2 ds, or that 2/3 du equals s to the minus 1/2 ds. Thankfully for us here, I see my s to the minus 1/2 hanging out over here. It's a root s on the bottom, so it's s to the minus 1/2. So there's my s to the minus 1/2 ds, which means I can sub directly here. And I get then the integral of 1 over u to the fifth times a 2/3 du, or 2/3 integral of u to the minus 5 du. That I can now integrate. It's a power, so I know what to do. 2/3 u to the minus 4th over minus 4 plus c. I'll end up here with a negative 1/6 when I simplify the fractions, and then a 2 plus 3 root s to the minus 4 plus c. There's a few examples of the substitution method, how to figure out what you should plug in for the problems, and how to go the extra steps when you need to get something you can actually solve with this method.